Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with predictive analytics and that too coverage on time series forecasting. In fact, we have already discussed this particular component, and in this particular lecture we specifically highlights for different models, time series models, and that too trend analysis, this is trend analysis, autoregressive model, moving average model and ARMA model. In our last lectures, we have discussed lots of time series forecasting. That means, we have discussed couple of models through time series data, and the idea behind this particular discussion is we have historical data of a particular variables, and that too we like to develop a models, whether it is a kind of NAP forecasting model or moving average models or smoothing models. So, in all the cases we like to use the historical data and develop a kind of forecasting model, and then we will go for the kind of prediction and forecasting for the future requirement as per the particular problem or as per the particular management requirement. So, in the similar lines we will discuss couple of other time series models through which we can do the similar kind of predictions and similar kind of forecasting by using the historical data. So, we in the same way we have to develop a model, and then we will get the estimated model on the basis of historical data. And before we go for prediction and forecasting, we have to check the kind of accuracy, and the similar kind of accuracy indicators we can use here to validate first the models, and then we will go for the kind of prediction and forecasting. So, let us start with the first the trend analysis, then we will proceed for autoregressive model, moving average model and autoregressive moving average model. So, in the trend analysis, so the basic structure is like this: formation and the forecasted informations, that is the difference between, in this case here, y t minus f t, and y t is the actual information of a particular variables and f t is the predicted informations of the of this particular variable through the forecasted model. And once we have the forecasted model and the forecasted information, so the difference between the actual information and forecasted information will give you the error component, and these error components are need to be evaluated first before we go for the prediction and forecasting. In fact, the particular structure we have already discussed in our previous lectures. So, here the similar kind of indicators like mean error, mean absolute deviation, mean absolute percentage error, mean square error, root mean square error. So, all these indicators are finally used to validate the model before we go for the kind of prediction and forecasting. So, what will it do actually? So, we start with the first trend analysis, and then we will follow by other models like autoregressive model, moving average model and ARMA model. In the trend analysis, the particular it can be a linear trend structure, it can be nonlinear trend structure, but generally we have a particular variable, and that variable's information is with respect to time. It may be annually, it may be weekly, it may be quarterly, but using these informations we like to predict a kind of structures, not exactly like moving average and NAP forecasting. It is through a kind of well structures, that is similar kind of structure which we have discussed in the case of regression analysis. So, what will it do technically here? In this case, so we first it is in yearly information. So, we like to plot these information. So, these are all actual values. So, this is the actual value, and then these are the actual value, and with the actual value we have a time period. So, what we can do first? So, we plot these actual values with respect to time. So, then if you join all these points, so this will give you a kind of actual behavior of these variables. Here in this case we are actually going to predict the cell structure of a particular company, and once you join all these points, then it will give you the actual movement of these cells for this particular company. So, what we need to do here? So, we like to develop forecasting model. So, which can give you the better forecasting or better structure through which you can actually analyze this particular sales figures, or we can discuss the particular business performance. So, what will you do here? So, means the technically how will you do this? This seems to be a predicted line, and this is actually the actual behavior of cells. So, then the difference will give you the kind of an error component. Once you get the error component, that need to be validated before you go for actually further sales forecasting or sales prediction. So, what will you do technically? So, having this particular information, so we will go to this particular trend analysis, and then we will get the trend line. So, the focus of the trend line will be like this. So, these are all kind of actual points, these are all actual points, and in between the line, straight line is called as trend line. So, we start with the first linear one, and similar kind of OLS package will be used here to get this particular trend line. And once you get the trend line, so it will give you the forecasted figures, and the actual figure and forecasted figure will give you the error component. So, now once you get the error component and the kind of structure indicators which you have, so we will validate the error component before we go the kind of forecastings. So, let us see how is this particular structure. So, the kind of structure will be like this. So, this is what the kind of time periods, and this is the actual cells, and now in the trend analysis. So, the time component can be used as x variables, and then we like to regress y upon x, where y is the actual cells and x is the kind of time periods. So, accordingly, so we will apply the simple linear equations, and then we estimate the linear equation through OLS mechanism, and the OLS mechanism structure will be like this. So, we start with a simple equation like this: y equal to a plus b t, and t represents the time period, and a is the parameter and b is the parameter. Initially they are unknown, and with the help of this data and the kind of OLS structure, so we can get to know the a value and b value. So, accordingly, so a value is here this much, and b value is this much, and then we will go for the kind of forecasting. For instance, in order to know the kind of structure, so what will you do? So, we can technically go to the Excel sheet and get to know how it is actually happening. See here. So, this is what actually the kind of figures. This is what the sales figure, yearly sales figures, and what will you do? So, we create a new x with respect to the time period, and the first year we represent 1, the second year represent 2. Likewise, we have actually 1995 to 2001. So, the first step of this particular trend analysis to transfer this 1995 2001 to 1 to 7. So, accordingly, we have now sales data which can be represented as a y, and x here which is represented by 1 to 7. So, as a result, so the first step of the process, you go to the data analysis, and as usual in the data analysis, so we choose the simple regression, and once you go to regression, so you can indicate to the dependent structure and independent structure. So, accordingly, so sales can be indicated as a dependent variable here. So, you can insert the kind of items. Then we go to the x series. So, where x information will be available from 1 to 7. So, the moment we will put OK. So, this will give you the linear regression results, and that to here this is a kind of linear trend analysis. So, that means we need actually a coefficient and b coefficient. So, the a is here 56.71 and b is 10.53. So, accordingly, you can go to the particular structure. So, here, so what will you do? So, we just estimate the particular sales figure, and on the basis of this parameter a equal to 56.7 for 714 and b equal to 10536, and then once you actually set the particular equation and you scroll it, then obviously it will give you the estimated figures. So, once you get the estimated figures and you can obtain the error component, which is the difference between the actual sales, this is the B column, and the forecasted sales, that is the D column. So, the difference will give you the error component, which is available in E column, and then again corresponding to each actual sales and forecasted sales. So, we will find the error terms. So, once you get the error terms, so the first check is to check the bias, that is the difference between actual sale and forecasted sales. So, the sum of the bias should be equal to 0, and accordingly we can have we can check the particular error validations through mean absolute deviation, mean absolute percentage error, mean square error, root mean square error. So, we have already calculated all these things, and then we just check it as usual the previous discussions. So, then you can validate. So, in fact, for any kind of models, so you once the forecasted model is ready, so you can get the error component, and following the error component you can get mean error, mean absolute deviation, mean absolute percentage error, mean square error, root mean square error. But now the question is whether the model is actually feasible one for the prediction and forecasting. For that we can have a comparative kind of structure, and the model which can be used for finally for the prediction and forecasting, that should have a minimum error, minimum mean absolute deviation, minimum mean absolute percentage error, minimum mean square error, and minimum root mean square error. So, accordingly we can decide which model should be finally used for the prediction and forecasting. Accordingly, so the model is available here in our case. So, this is what the forecasted figure and the error component, and then finally the particular validation is validated through mean absolute deviation, mean square error, and mean absolute percentage error. So, likewise, so we can actually plot this one. So, this is the actual sales, and this is the actual sales, and this is the predicted sales, and this particular structure is called as trend analysis. So, the trend analysis can give you now this is available for a particular periods, and for any kind of future requirement you just enter the particular date. So, automatically it will give you the forecasted figures. So, in this way, so we can actually develop a trend analysis and go for the kind of predictions. So, these are all mathematical structure through which you can apply least square mechanism to find out the trend line. So, what we have already discussed. For a another example which you can cite here to check the particular validation. So, this is the early information 2012 to 2016, and we like to estimate the trend value for 2017. And again, so we can start with a simple structure linear model y is equal to a plus b x, and the idea is to get the a value and b value. Once you get the a value and b value, so now for x we can start with 2012 1, 2013 2, 2014 3, 2015 for 4, and 2016 5. So, obviously, for 2017 the series will be 6. So, accordingly, once you get a value and b value, so then put x 6, then by default we will get the forecasted figure of the sales for 2017. So, likewise, so these are the mathematical structure structure through which you get the particular model. So, this is the estimated model 5.2 plus 1.6x, and then accordingly, so the trend structure. So, this is the estimated model. So, now for 2017, so this is the kind of figure need to be adjusted here. So, then accordingly we can get the forecasted figures. So, this is how this linear structure through which you can do the predictions and get the kind of forecasted figure for the next years. So, these are the process through which we can actually do the kind of trend analysis, and then we will get the kind of structure prediction structure and forecasting structure. So, it is not necessarily that we can every time go for linear trend. So, we can also follow the nonlinear trend. So, what is the usual structure? We have to just plot the data and check the movement of a particular variables. So, corresponding to the data visualizations, that is through graphically. So, we can know the particular functional form, and if the functional form shows second degree equation, then again so OLS mechanism can be applied accordingly, and then you can again re-estimate and get the parameters. In this case this can be like this. So, it is a secondary equation. So, here we need to know what is A value, B value and C value. So, for that for the OLS structure, so we have a 3 standard equations, structural equation through which you can solve the particular problem. So, similarly, we have a y, that is the actual cells, and x is the time informations, then x is represented as a t, and then so we can get x squares and other components through which you can actually solve these 3 equations, and that to get the values of a, b, c. So, once you get a values of a, b, c, so this will be the forecasted figure, and then we have actual figure and the forecasted figures. By default, we will get the error component. Again, we will follow the similar mechanism to test the model first before we go for the kind of prediction and forecastings. So, that means technically, so the trend analysis will help you to get the kind of prediction of a particular variables, and as per the kind of business requirement or management requirement. So, likewise the second type in the time series, second type of structure which I like to discuss here is a autoregressive scheme, and we have a 3 models altogether here: autoregressive model, moving average model, and autoregressive moving average models. That means the combination of autoregressive and moving average. In the autoregressive models, the typical structure is the actual cells need to be predicted with previous cells. That is the that is actually technically we can club with or connect with a lag variables. So, y t represents cells at a current time frame, and then followed by the previous cells, that is represented by y t minus 1s, and y t minus 2, y t t minus 3, and so on. So many lag variables you can create. So, once you get the lag variables, so the actual actual cells at a particular time can be connected with the previous time periods, and then we will get again the forecasted model. And like the previous trend analysis, so we have actual cells and the predicted cells, then you will find the error component, and again the error component need to be tested or validate before you go for the prediction and forecasting. So, here the major issue is how many lag lengths you can create for this particular autoregressive models. So, let me first give you the structure of how the lag variables can be created, then we will go for the kind of prediction. So, what will you do here? Okay, so this is what the particular model. So, you go to this particular autoregressive model. See here. So, this is the data set, and let us say this is a saving of a particular economics, and that is available from 1991 to 2016, and we need to predict the saving rate for 2017, 2018 and 2019, and that too through autoregressive model. So, by default the saving data for this time period 1991 to 2016, so it can be represented as a y t, and then so the way you can create the lag variable is like this. So, just copy the particular variable, and then you can paste one lag behind. So, by default so like this we have already created here. So, y t 1, y t minus 2, then for y t minus 3 we can paste it here. So, likewise one lag behind. So, by default now this is y t, and then this y t can be connected with y t minus 1, and again so y t can be connected with y t minus 2, y t can be connected with y t minus 3. So, that means we can have here one model with y t minus 1, again we can connect with y t minus 1, y t minus 2, that means 3 variables simultaneously, where y t minus 1 and y t minus 2 can be treated as independent variables, and y t is the dependent variables. So, likewise again we can create a third lag variables y t minus 3, then again y t can be connected with y t minus 1, y t minus 2 and y t minus 3. So, that means since we have actually more data points, so we can create actually n number of lag variables. So, obviously the first issue is how many log variables can be connected at a particular point of time. So, that means it is a very interesting kind of structure. So, so what is the challenge that first you fix the log length, then then you go for the kind of estimation. So, there are different indicators through which you can fix the log length, but manually you can test yourself and check the particular structure. What we can start means what we can do, we can start with the first yt and yt minus 1, like simply go to the data analysis, and then what will you do? So, you can connect with the yt same regressions, and then we can connect with the particular indication. So, this is okay. So, we can start here. Okay, so same data point. So, we can start here from this data to this data. Okay. So, this is x indications, and then accordingly, so your independent variable will be yt minus 1. So, that will start from the second second unit, and as a result you just put OK. So, this will be give you the kind of moving average models where yt as a function of yt minus 1s. So, likewise, if you add yt minus 2, then again, so we have actually intercept, then b1 coefficient, b2 coefficient. So, the model will be extended accordingly. So, technically, so we have actually a particular variable, but we can create n number of variables through which you can actually predict the particular saving rate. So, obviously, the first issue is how many log lengths you can check. So, what will it do? So, you connect with the yt minus 1, this is the first models. Again you can connect with the yt minus 1 and yt minus 2, this is the second model. Then yt minus 1, yt minus 2, third model. So, likewise we can have a plenty of models. Every time you estimate and get the error component, and again you can find out the model indicators, mean absolute deviation, mean square error, root mean square error. Then now for yt minus 1, then yt minus 1, yt minus 2. So, every case you have to find out to error component and all the model indicators like mean square error, mean absolute deviation, mean absolute percentage error. Then finally, you check where the particular model is very reliable or very perfect with respect to minimum of all these indicators like mean error, mean square error, mean absolute deviation, mean percentage error. So, once you confirm that this particular model is perfectly fit compared to other models, then you will go for the kind of prediction and the kind of management requirement. So, obviously, the first structure is here, the choice of the log length, and we have a some standard indicators through which you can check the log length. So, there is a AIC statistic and SIC statistic through which you can find out the kind of optimum log length through which you can actually indicate the particular structure before you go for the estimation. Otherwise, manually you have to develop a model every time and check, then finally you can do the comparative analysis and fix which model is perfectly okay for this particular prediction and forecasting. So, so this is what the kind of autoregressive structure, and accordingly we can have another model called as moving average model. So, in this context, so it is actually similar lines like it is the similar line structure, similar structures here like yt can be forecasted with error component. So, that means technically we start with simply let us say yt equal to function of yt minus 1s like the moving average model, and we can have also model like yt as a function of yt minus 1s and yt minus 2. So, that means we have a n number of ways you can develop model for for this particular structure in the moving average structures. You can start connecting with first yt and yt minus 1, and then according to this particular structure your model will be simply yt equal to a plus b yt minus 1 and plus error terms. So, the first requirement is to find out a and b. So, then once you get a and b by simple regression, then you can get the error component which is nothing but e equal to yt minus forecasted figures ft, and once you get the error component. So, this will be treated as et. So, it is a variable now. So, like yt we can create yt minus 1, yt minus 2, yt minus 2 etc. So, we can also create et minus 1, et minus 2 and so on. So, for this what we can do, So, you can go to the particular Excel sheet and then you check here. So, what will you do here? So, in this case what will you do? So, you go just same data set saving rate. So, we have actually y t these ones, then this is y t minus 1, y t minus 2, which I have already mentioned how to create y t minus 1, y t minus 2, y t minus 3, y t minus 4. And for E t, so what will you do? First go to the data analysis and then you just connect with the y t and y t minus 1. For this we have already indicated here the particular requirement. So, the first requirement is to indicate y t information, and that to from B 3 to B 27. Then again, so you can give the indication about the independent variables. In this case, independent variable will be y t minus 1, and again from B 3 to C 3 to C 27, and then you just estimate. So, what will you in this case you will get the A coefficient and B coefficient. Once you get the A coefficient and B coefficient, then you come to the again Excel sheet, and then you develop the estimated equations by putting A equal to 100 for 0.965 and B 0.982. So, you can actually just connect with y t minus 1, then you get the error component. So, now once you generate the error component, first you check the all the biasness and mean square error, etc. But in the requirement of moving average, we need to create error component. So, that is the difference between actual cells, that is y t, and the forecasted cell, and as a result you will get the error component like this. So, now once you get this error component, so this error component need to be actually pasted one point behind every times like this, like this. So, you can actually connect continuously like this. So, that you will get actually this is E t, and again this will be E t minus 1, and similarly you can create E t minus 2, E t minus 2. So, like this you can create a number of error terms. So, now in the moving average structures, so the final model will be so y t, which can be connected with the error terms. So, now instead of y t minus 1, now the model will be y t upon error terms E t, and then you go for the estimation. Similarly, y t can be connected with E t and E t minus 1, then y t can be connected with E t minus 1, E t minus 2. So, again we have a plenty of different models. So, every times you have to estimate, then get the error component and check the validation of error component, then finally fix which model is perfectly fit for this particular prediction, and again you go for the the kind of management requirement that is with respect to forecasting and the kind of the saving prediction of an economy, right. So, what will you do here? Like the previous case moving average in autoregressive models, in the case of moving average, so same problems will be with respect to lag length, and obviously you go by different kind of models and check all these error components, and finally you pick up a particular model which is having actually minimum error or minimum root mean square error or minimum mean absolute percentage error, then finally that model will be used for forecasting. So, again the choice of the lag length is very important, because what is happening if you connect with the y t with more number of error lag variables or more number of lag dependent variable, then obviously, so what is happening you have a less degree of freedom to validate the particular model. So, obviously, the first and requirement of this kind of model is to fix the optimum lag length, then you can go for the kind of estimations. Once you go fix the optimum lag length, so you will get the particular structure, and then the estimation process will give you the kind of forecasted model. So, once you get the optimum forecasting, so the error will be finally checked and validate before you go for again future forecasting at the kind of future predictions. So, the third model corresponding to autoregressive model and moving average, the third model is actually clubbing of both autoregressive and moving average, that too it is called as a ARMA models. So, in the ARMA models, so the yt can be connected with the kind of this is yt connected with the lag of the y y variables and the lag of error component. So, that means, in the first steps you connect with the yt and yt minus 1 and then get the parameters value. So, on the basis of the parameter value you can get the estimated equation. So, the actual information and the estimated information will give you the error term, and once you get the error terms you can create log error variable, and then finally, in the Excel sheet we have actually a dependent variable yt followed by independent variables, the log variables yt minus 1, yt minus 2, yt minus 3 and so on, and against the error log variables ut minus 1, ut minus 2, ut minus p, and accordingly. So, you can fix up a particular structure and then go for the kind of prediction. For instance, corresponding to, let us say, this is actually autoregressive structure and this is moving average structure and this is ARMA structure. So, in the case of autoregressive structures, so let us say we start with the first one. So, yt equal to function of yt minus 1, and here in the moving average yt as a function of et minus 1s or et simply, or in the case of ARMA. So, yt is a function of both yt minus 1s and et minus 1. So, like so, this is actually similar kind of structure. So, in one case you are connecting the actual variable with the log variables, in another case you are connecting with the actual variable with the error log variables, and then finally, in the third case, that is autoregressive moving average, we are just clubbing the autoregressive scheme and moving average schemes. Then we have a different kind of models where the particular variable will be connected with the log of that particular variables and the log of the error variable, which is derived from the particular variable yt. So, obviously, the same problem is here, like fixing optimum log length. So, once you fix the optimum log length, then you find out the estimated equations. Then once you get the estimated equations, the error component can be generated accordingly, and once you get the error series, the forecast actual cells and the forecasted cell, then finally you will get the error component again, and that error component need to be validated before you go for future forecasting and future predictions. So, likewise this is a kind of time series structure through which you will have a interesting structure through which you can get the particular prediction kind of environment through which you can do the proper predictions as per the management requirement. So, what we have actually discussed in the last slide. So, with respect to the autoregressive model, moving average models and autoregressive moving average model. So, every time what we have actually seen, so we have actually plenty of scopes to develop simple bivariate structure to a multivariate structure. So, that means we have a kind of flexibility here to develop a very interesting multivariate framework through which you can do the kind of prediction as per the management requirement. But the mathematical it is very easy to develop or connect the models and extend the model from bivariate to multivariate. But finally, so the obvious choice is actually log length, because you cannot have a multivariate kind of infinite structure. So, you start with yt, and if you have actually more data points, you can create n number of log variable with respect to both the dependent variable and the kind of error variable. So, technically we have actually plenty of models through which you can actually do the kind of forecasting. So, obviously, the first hand choice is to check the optimum log length, and that is one of the important step in the case of autoregressive models, moving average model and autoregressive moving average models. So, once you actually fix the optimum log length, then it will give you the kind of structure through which you can proceed for the prediction and forecasting. So, what I have actually mentioned earlier, so the choice of log length is very important for both these models, that is autoregressive and moving average, and that too again ARMA model. And so, the choice of log length to fixing the kind of optimum structure. So, we have actually AICA information criteria, that is AIC statistics, and then SIC statistics. So, the particular formula is here available to report the AICA information criteria, that is AIC statistic, and this is SIC statistics, and here RSS is a residual sum of squares, that is actually derived from the estimated equations, and then K and N depends upon number of regressors and the kind of sample size. And once you get actually the particular estimated equations, so by default ANOVA analysis of variance tables will provide you explained sum of squares, residual sum of square, and total sum of square, but a residual sum of square is the input to the AIC statistic and SIC statistics. And once you get all these things, so calculate the AIC statistic and SIC statistic, like the kind of model choice with respect to mean square error, mean absolute deviation, mean root mean square error. Here a final models with respect to log length, particular log length depends upon the minimum value of AIC and SIC statistics. So, so it is a kind of iterative and continuous process with respect to fixing the optimum log length and fixing a particular models, whether we will go ahead with move say autoregressive schemes or moving average schemes or the kind of ARMA schemes. So, depending upon a particular structure and the kind of best predictions, we have to first pick up a particular model as per the requirement, and then we will go for the prediction and forecasting, which is as per the management requirement, or the then in that context you can go for having good management decision as per the particular business requirement. So, so likewise we have actually discussed couple of time series techniques, and in all these time series techniques you have a historical data and you have to develop a forecasting models, and with the help of forecasting models you will go for future prediction and future forecastings as per the kind of business requirement or management requirement. With this we will stop here. Thank you very much. Have a nice time.